Hi guys, in this video we're going to be talking about the neutralization reaction. We're first going to talk about the reaction in general, then we'll look at an example of an equation, and then we'll go through a couple of worked examples together. So firstly, what is a neutralization reaction? So a neutralization reaction occurs when we mix an acid and a base or alkali, and then we say that this solution is then neutralized. And what is happening when it's neutralized is that the hydrogen ions that are freed when the acid is dissolved in water bonds with the hydroxide ions that are freed when the alkali bonds in water. Now there are other ions that can be basic or alkalis, but we're not going to talk about them in this video. We're going to stick to hydroxides because that's the one that we're going to see most often. And when these two bond together, those hydroxide and those hydrogen ions, it produces HOH, or more formally H2O, water. And then those ions that are left over are going to form some sort of ionic salt. So the general equation for this reaction is an acid and an alkali react to form salt and water. So let's have a look at an example reaction of this acid-alkali reacting to form salt and water. Now the most common one you're going to see is looking at hydrochloric acid and sodium hydroxide. This is often used as the first example of a neutralization reaction that you will see because it is very simple and it has a salt that is familiar to us, sodium chloride. Now, sodium chloride is table salt that you might put on your dinner. However, when we talk about salt, in the general terms, we're talking about any ionic compound. So it's not necessarily, when we say a salt is formed, it's not necessarily going to be sodium chloride. However, it is in this circumstance. So if we look at the chemical formula for this reaction, we see hydrochloric acid, HCl, and sodium hydroxide, NaOH. And what happens here is our hydrochloric acid, the hydrogen ions from that hydrochloric acid, and the hydroxide ions from the sodium hydroxide, there is what's going to form our water. So that goes to form there. So what we're left over with is our chloride ion here, and our sodium ion here, and that's where we get this sodium chloride from. So that's basically how this reaction works. Let's have a look at another example and we'll work through the products together. So in this example we have sulfuric acid and potassium hydroxide. Now we've got sulfuric acid, which has got acid in the name, so we know that's an acid. And we've got potassium hydroxide, so alarm bells should be going off that this is an alkali. So we need to think back to our acid-alkali reaction or a neutralization reaction and remember what the products are going to be. And we remember that the products of this reaction are salt and water. So, good stuff. Our equation is half done for us. One of our products is going to be water. Now at this point, I find it's a good idea to start working out what our chemical formula is to work out what our other salt is going to be. So I'll get the chemical formula for water, and then we'll go from there. So firstly, we've got our sulfuric acid, and we can look up our acid table, and we work out that sulfuric acid is H2SO4. Now potassium hydroxide, potassium is K, hydroxide is OH. Potassium is in the first column, so it's K+, hydroxide OH-, from our polyatomic ion list. So these numbers are the same, the positive and the negative cancel each other out, and we don't need to balance anything there. Alright, now we need to work out what is going to make up our water. And as I said before, it's the hydrogen ion from the sulfuric acid and the hydroxide ion from the hydroxide or the alkali, and these are going to come over here to make our water. So our salt is going to be made up of the ions that are left over. So if we have a look at those ions, we have sulfate and potassium. So our product here is going to be form potassium sulfate. Now we need to have a look at whether these ions are balanced. So potassium, as we said, first column, so it's plus. Sulfate, our polyatomic ion list, tells us that this is 2 minus. So these are different numbers, so we're going to have to swap and drop here. So the 2 from the sulfate comes down to here on the potassium, and the imaginary 1 on the potassium comes down and forms an imaginary 1 here, but we don't need to write that. Great, so we can get rid of those valencies now. Alright, the last thing we need to do is make sure that this equation is balanced. So we'll start with our metal. So in potassium, we've got 1 potassium in the reactant side, and we've got 2 potassium on the product side. So that's going to be a problem. So we can't magic that from nowhere. So we'll have to come over here and put a 2 in front of our potassium hydroxide. So now we've got 2 on this side and 2 on this side. So that's all good. Now we'll have a look at our ions. So on this side we have 1 sulfate, which is good, and on this side we have 1 sulfate, so we're also good there. Now we'll move on to our nonmetals. No other nonmetals. So next will be oxygens. So on this side we have 2 oxygens, because we have 2 potassium hydroxides, and on this side we have, we've only got 1 oxygen here. So if we put a 2 out the front of that water, that'll give us 2 waters and 2 oxygens. Now remember, these oxygens here and here have already been accounted for as our ions, so we don't need to worry about those. So now on this side we've got 2 oxygens, which is good. Problem now is that we have 4 hydrogens. So we need to come back over to this side. We've got 2 hydrogens there, so we're going to need 2 hydrogens there. Well, that's not a problem at all. That's actually balanced. So now we've got our balanced equation. All is left that we write our word equation up in here. Potassium sulfate. And we've done this equation. Okay, let's have a look at another example. Hopefully this one's a bit harder. So we've got nitric acid and calcium hydroxide. So the first thing that we need to do is recognize what type of equation this is, and we've got nitric acid, which has acid in the name, and hydroxide, which is an alkali, so we know this is going to be a neutralization reaction. So we remember our general equation, which is an acid and an alkali reacts to form salt and water. So as we know, the first part is done for us, and we'll now start looking at that chemical equation. So we'll put our water in there. So we'll look at our acid table, and remember that nitric acid is HNO3, and calcium hydroxide, calcium Ca, and it's in the second column, so it's a 2+. Hydroxide is OH-. Now these numbers are different, so we're going to have to swap and drop. So I'll have to put a 2 down here, and the imaginary 1 goes to the imaginary 1 there. Now the thing we've got to remember here is this is a polyatomic ion, so we need to put those brackets around the OH to show that it is 2 hydroxide ions, not just 2 hydrogens in this compound. Now we've done that, we can get rid of those valencies. Alright, so now we'll have a look at what is going to form that water. So on this side we have our hydrogen from our acid, and our hydroxide from our calcium hydroxide, and that's going to form our water, our H2O. So what are we left over with? Well, once the hydrogen's gone here, we're left over with a nitrate, and once the hydroxide's gone here, we're left with a calcium. So that is going to be our salt, our calcium, and our nitrate. So next thing we need to do is make sure that these ions in our calcium nitrate are balanced. And as we said, calcium's this second column, so it's 2+. And from our polyatomic ion table, we know that nitrate is -1. So again, we need to swap and drop here. So we'll bring this 2 down to the nitrate, and we'll bring this invisible 1 to here. Yep, I've done that in my head. And now I just need to remember to put those brackets in, because it's 2 nitrates, not just 2 of the oxygens. And we can get rid of those valencies. Good stuff. So our last step is to work out whether this equation is balanced. So on this side, we'll start with our metals. We've got 1 calcium and 1 calcium, so that's all good. We'll next have a look at our ions. So here on this side, we have 1 nitrate. On this side, we have 2 nitrates. So that's a problem. We're going to have to bring a 2 over here. So now we've got the 2 of those nitric acid molecules. So we've got 2 nitrates on this side and 2 nitrates on this side. Now we don't have any other nonmetals, so now we'll look at our oxygens. So on this side, we have 2 oxygens. Remembering we don't need to worry about these ones because they form part of the ion, same as these ones. So here we have 1 oxygen. So we need to put a 2 out in front of there. So we now have 2 water molecules. So our oxygen is now balanced. Now we can move on to our hydrogen, and we've got 4 here and 2 here and another 2 here. So that's 4 on that side as well. So this equation is balanced. So finally, we'll just put our word equation into this one to finish it off. Calcium nitrate. Now we have our equation finished. In this video, we've talked about the neutralization reaction, and we've talked about it in general, that an acid and an alkali or base react to neutralize each other, where the hydrogen ions from the acid and the hydroxide ions from the base or alkali bond together to make water. We've talked about the general equation, which is acid plus alkali reacts to form water and salt. And we've looked at a couple of example equations where we have our acids and alkalis and worked out what those ionic compounds that make up the salt are, and that the metal comes from the hydroxide or the alkali, and the non-metal comes from whatever the non-metal is in the acid. Thanks for watching, guys. Peace out.